In this section, we are going to discuss how two PCs communicate with each other. So in our diagram, you can see that we have two PCs, PC1 and PC2. The IP address of PC1 is 20.1.1.1 and the IP address of PC2 is 20.1.1.2. The MAC address of PC1, we are assuming it is 1111 and the MAC address of PC2 is 2222. Now, when there is no communication, you can see that we have the ARP table of PC1, which is having the IP address and MAC address of PC1 only, but there is no entry for the MAC address and IP address of PC2. Similarly, you can see the ARP table of PC2. There is no entry for the IP address and MAC address of PC1. You can see only the IP and MAC of PC2 in the ARP table. Now, when we ping from PC1, now you can see that as soon as we type the command ping 20.1.1.2, so the ICMP protocol is going to generate a echo message, right? So something like that. So an echo message will be generated. And what type of echo message will this be? So it will be an echo request packet, right? ICMP echo request type packet. So the type code for ICMP echo request message is type 8. Okay. So now ICMP is going to hand over this particular packet to IP protocol at layer 3. And now at layer 3, the IP protocol is going to populate different informations. So something like this. So ICMP echo request is received, right? And then the IP protocol is going to populate the source IP, the destination IP, and also each layer in the USI model, they are going to track about the information that the upper layer is providing to them. So for example, in this case, the IP protocol received this particular information from the ICMP protocol. So there is a protocol field that it is going to populate so that it can keep track this particular information that who provided this particular data to me. This will be helpful. We'll see this when we will see the information from the receiver side. So in the protocol field, it is going to populate number 1 because the protocol number for ICMP is 1. Also, it is going to populate the TTL information, right? So let's say if you are using the Windows, so the TTL value will be 128. This information, this whole information at layer 3, it is called a packet, right? So at layer 3, this particular information is called a packet. Now, IP protocol is going to hand over this protocol to ARP protocol at layer 2, right? So PC1 is using Ethernet and PC2 is also using the Ethernet. Now, for Ethernet, we have the particular protocol which is ARPA that works at layer 2. So IP protocol is going to hand over this particular information or this packet to layer 2. So now layer 2 received what? A packet, right, from IP protocol. So likewise, as we discussed, that each layer is going to keep a track of who provided this information to me. So there is a type code field. There is a type code field. Sorry, wait a minute. So there is a type code field for IPv4 because we are using IPv4 addressing, right? So it is going to keep a track of this. So the type code for IPv4 is 0x0880. I think this one is for IPv4. Then layer 2 is going to populate what? The source MAC address, right? The the MAC address against the source IP. Source IP is 20.1.1.1. It is going to check the ARP table and it can populate the MAC address against this particular IP address. Now it needs to populate the destination MAC address. Now again it is going to refer the ARP table, but in the ARP table you can see there is no entry for the MAC address against the destination IP, which is 20.1.1.2. So now ARPA protocol is going to take help from the ARP protocol, okay, to find out the destination MAC so that this frame can be created, right? Because if ARPA protocol is having no knowledge of the destination MAC address, then it cannot create this particular frame. So that is why now ARPA is going to take help from ARP protocol and a ARP packet will be generated. So now let's see what will be the content of that. So ARP is going to populate different informations. So now let's see what will be that. So there will be the source IP, which is 20.1.1.1, right? There will be destination IP, which is 20.1.1.2. Then there will be the source MAC address, right, which is 1111, right? In the destination MAC field, it will be all zeros. We are talking about the ARP packet, okay? And there is one more field which is important, that is the opcode field. Opcode field will be one which specifies that this is this particular packet is the ARP request packet, okay? Okay, first let's clear the previous text. Just give me one moment. Let me populate it again. So we'll be having the source IP, the destination IP. In the source MAC for ARP, it will be 11111. In the destination MAC field will be all zeros because we need to know who or what is the MAC address against IP address 20.2. Then there will be one more field which is the opcode. Opcode will be one which specifies that this particular packet is the ARP request packet. Okay. Now again the ARP protocol is going to hand over this packet to ARPA protocol at layer 2. Now ARPA will receive this ARP request packet, right? ARP request packet. Now, as we discussed that each layer they are going to keep a track. So there is a type field for the ARP protocol. So 0x0806. So this is the type code for the, or this is the ARP protocol type code. Okay. Now it is going to put the source MAC address, which will be 1111, and in the destination MAC field there will be OLF, right? Now the frame will be handed over to physical layer, because now you can see that at layer 2 the frame is created, right? Now the frame will be handed over to the physical layer, which is going to send this particular information to PC2, right? So at receiving end, the frame will be recreated and then it will be handed over to the ARPA protocol at layer 2, correct? Now ARPA is going to check the destination MAC. So what is the destination MAC it received in the frame? That is OLF. So that is why the frame will be accepted. Now this particular layer 2 information will be removed. Okay, so now ARPA is not ARPA, the ARPA protocol is going to remove the layer 2 header, which is this source MAC, destination MAC, everything. Now it needs to decide that where to send this remaining information, right? So we have this particular remaining information, correct? So now ARPA is going to check the type field. In the type field, it will get to know 0x0806. It means that it needs to, which is the type code for ARP protocol. So now you can understand that if we do not have this particular type field, or if the uh, each layer do not track the information that they received from the upper layer, then at the receiving end they will not be able to decide where exactly they need to forward this particular information. Now you can see that when ARPA protocol removed this layer 2 header, it is going to check this type field and it will get to know that it needs to send this information to the ARP protocol, correct? So now this particular information will be sent to ARP protocol by the ARPA protocol. So we have discussed till point 8. You can see that it is going to send this information to ARPA protocol. Now the ARP protocol will check the destination IP. So what is the destination IP? So the destination IP in this ARP packet is 20.1.1.2, right? Which is the IP address of the PC2. That is why this particular information will be accepted. Now in this particular packet, if you remember that there was one opcode field, right? The opcode was 1. So that is why now the ARP protocol will understand that, okay, it is an ARP request packet. Okay, so ARP will update the source IP and source MAC address in the ARP table and will generate the ARP reply packet, right? So now you can see that as soon as the ARP request reaches to the destination, so the ARP protocol is going to populate. It will open this particular information, where because in this information already there is the source MAC, which is 20.1.1, and the MAC address of PC1. So it is going to populate source MAC and destination MAC into its own ARP table, and now it will generate the ARP reply packet. So the content of ARP reply packet will be something like this. So what will be the source IP in this case? The source IP will be 20.2. The destination IP will be 20.1. The source MAC will be the MAC address of PC2, which is 2222. Destination MAC is 1111. And now we'll be having the opcode, because this particular packet is the ARP reply packet, so opcode will be 2. Now same process will be followed. The ARP will hand over this packet to ARPA protocol at layer 2, and ARPA is going to generate the frame. So ARPA protocol received what? The ARP reply packet, right? It will do the same stuff. It is going to keep a track of who provided this information to me. So the type field will be populated with the ARP protocol type code, which is 0x0806. It is keeping a track of this. Now the source MAC is 2222, and the destination MAC will be 1111, right? So this is the frame generated by layer 2 or the ARPA protocol. Now you can see that at point number 11, that the same process will be followed. The frame will be received by layer 2. So the ARPA is going to check the destination MAC. So what was there in the destination MAC, if you remember? So there was the destination MAC was the MAC address of PC1, which was 1111. So it has its own MAC address. So this particular frame will be accepted at layer 2. Now the layer 2 header will be removed. And now ARPA needs to decide where to send this particular or this remaining information. So it is going to check the type field. In the type field, it is going to find out 0x0806, which is the type code for ARP protocol. So it is going to hand it over this particular information to ARP protocol. Now ARP will check the destination IP. What was the destination IP in the packet? That was 20.1.1.1. So this particular packet will be accepted. Now similarly, the op code will be checked. So the op code in this particular packet was 2, which means that it is the ARP reply packet. And now the ARP is going to populate the ARP table with the IP and MAC of PC2. This is not PC1. This is PC2. Okay. So this is how the PC1 is going to learn the MAC address of PC2, and in this whole process PC2 is already populated the information of MAC and IP of PC1. So now when the next packet comes in, so the layer 2 can refer to the ARP table and populate the destination MAC address. Hence this time our communication will be successful. Now layer 2 does not need to consult the ARP protocol, because earlier the problem was that at layer 2 the ARP protocol was not able to generate the frame because in the ARP table there was no information about the destination MAC. So this is how the two PCs communicate with each other. We can also see it with a practical so that I can show you these different fields. If I go to event G, so I have PC1 and PC2. If I go to PC1, if I do show ARP, you can see that the IP address of PC1 is 20.1.1 and it only has the information of its own MAC address, which is 11111, right? If I go to PC2, I go to PC2, and if I say show ARP, you can see PC2 is having the information of its own IP address and its own MAC address. There is no information about PC1's IP and MAC address, right? Let's also capture this particular interface. Ethernet 0x0. Now if I go to PC1 and if I say ping 20.1.1.2, now you can also notice that one packet is dropped because there was the ARP process going on in the background, right? And later the packets are successful because already the ARP table is populated with the IP and MAC information, right? So if now, because the communication is successful, you can see that in the ARP table of PC1 we have the IP address of PC2 and the MAC address of PC2. Similarly, if you go to PC2, you can see the ARP table of PC2. Now we have the information of IP and MAC of PC1. Now let's go to sharp and see. Now you can see the very first packet is an ARP packet which says that who has this particular IP address 20.1.1.2 and who is asking this information 20.1.1.1. If we open this packet, Now you can see that we have an ARP packet, right? And in the ARP packet, you can see the source IP, right? Which is the IP address of PC1. This target IP, the IP address of PC2, which is 20.1.1.2. Source MAC, you can see that 1111, which is the MAC address of PC1. And as we discussed that in the ARP packet, the MAC address or the destination MAC will be all zeros. And there is the opcode field, which is opcode 1, because this is the, you can see here also, this is the request packet or the ARP request packet, right? In the layer 2 frame, you can see that the source MAC is the MAC of PC1. You expand it, and the destination MAC is OLF. Also, as we discussed that each layer is going to keep a track of the information where exactly they received it from. Now you can see that this particular ARP request is sent to the ARPA protocol by ARP protocol. So it is going to put the or populate the type field with 0x0806, which is the type code for ARP protocol that we already discussed. We discussed everything. I'm just showing you it into the Wireshark. So this was the very first packet, right? Similarly, if you see the request or the ARP reply packet, now you can see that this is the ARP reply. You can see here also, if we expand this ARP reply, you can see that if you go down, we have the source IP. Source IP is the IP of PC2 20.1.1.2. Target IP is 20.11.1.1, which is the IP address of PC1. We have opcode this time too, because this is ARP reply packet. When we saw the ARP request packet, you saw that the opcode was 1, which means that was the ARP request packet. And likewise, you can see the layer 2 header information. You can see that now this time the source MAC is 22222 and the destination MAC is 1111, and it is also keeping a track of the upper layer. So who provided the information? Now the ARP type code is populated here. So now you can see the other packets also. When we have the ping request or the echo request and echo reply, you can see that after the ARP is successful, a new packet, when the new packet was generated, we have the ICMP protocol, right? In the ICMP, we discussed that the request, the echo request packet, it is having a type code of 8, right? Then we have the IP protocol. In the IP protocol, the IP protocol populated the information source IP, destination IP, and also it is going to populate the TTL value. So because in my example, I'm using the normal routers, I just changed the icon to PCs. So on Cisco devices, you can see that we have the TTL value of 255. And also, as we discussed that the IP protocol is going to keep a track of information that is provided by upper layer or by that the information that is it received, right? So the IP protocol it received the information from the echo request from the ICMP protocol. So it populated the protocol field and the ICMP protocol number is 1, right? And now you can see that because the ARP table is already populated, so we have the information of source MAC, which is 1111, the destination MAC 2222, and the type code we discussed for IPv4 0x0800, right? So I mean the Ethernet layer, it is also going to keep a track of the information it received from upper layer. So this also we discussed. And now I'll show you a reply also from PC2 to PC1. We have the echo reply this time. Now you can see we have a echo reply, and the type code for echo reply is 0. So the type code for echo request was 8, and now the type code for echo reply is 0. And then we have the IP protocol. We have the same source IP, destination IP. We have the TTL value here. We have the protocol for ICMP, which is 1, and the same information. We have the source MAC, the PC2 MAC, the destination MAC as the PC1 MAC, and likewise the type code for IPv4 address 0x0800. So this is how two PCs communicate with each other, and how the address resolution protocol works in this particular communication. So that's all for today. See you in some another video, and thanks for watching.